All right, welcome everybody. It's March 1st, and we're continuing the discussion today. I think now this is the fourth day where we're going into special purpose nodes. Lots to unpack there still. So we're continue that conversation. Before we get into that, I'll throw it to Stephen if there's any updates you've got to share as it pertains to the Leap software update status.
Yeah, absolutely. So I know that I missed last week due to a conflict. However, I understand that there was some elaborate discussion around exploring an alternative three-strike rule just related to some challenges that some networks have been facing. We are going to dedicate some resources towards attempting to address that, and we'll have some more announcements once we've covered a bit more ground there. The other big thing that we're excited to make mention of is that we're zeroing in on a code freeze date for Leap. Looking at basically a week from today is what we're shooting for right now, which would of course mean that in some short order thereafter, we'd be looking to roll out the first RC for Leap v4.0.0. No official commitment on that official RC date, but we've got that target code freeze date, and our hope is to follow fairly quickly thereafter. That, of course, will also lead to a cascade of other releases across CDT and then a couple of Dune things, but the meat of it for the most part will be across Leap and CDT. So really excited. We're marching forward. We said March, April, so I think we're still on track.
All right.
Can I ask a question about three strikes?
Yes, you may.
If we have this new enhanced three strikes rule, do we need subjective billing?
That's a bigger question than I'm qualified to answer on the spot. But you know,
more of a Kevin question, I guess.
That's why Kevin is smiling.
Yeah, the short answer is yes. The three-strike rule is, targeted at certain targeted actions. I won't say attack, but actions. And so they really are targeting two different things.
All right. Cool. Just always looking to simplify the user experience if we can. So we can't here, then we're going to make it more complicated because different node operators will have different three strikes rules.
Yes, that will certainly be the case. So the idea here is to give you, a little bit more in your arsenal for as a node operator, BP, being able to, tweak some things. It's still, it's not going to be the end solution by any means, right? I mean, there's still the larger effort work of new resource models that we want to explore in the future. But as a interim solution, or interim mitigation. Yes, this is it seems to be low-hanging fruit, so I think it makes sense to go ahead and provide this option and see, cat and mouse. We'll see what this does for us. See what happens next.
All right, perfect.
Yes, in honor of simplifying the experience, something for everyone to chew on is that there are opportunities to simplify the experience on other networks in time if they consider any sort of changes to some of their resource modeling and stuff. Obviously, that's a much bigger, complex conversation to have, but the more that we're aligned at that root level, the easier it will be to kind of play with these cat and mouse games over time.
Yeah, I think if Power Up was better, maybe more people would adopt it. I don't know.
I understand.
UX on Power Up is not very good.
I don't know if you've seen the recent WRF stuff, but it's getting a lot better.
I'm looking forward to that. All right. Any questions on three strikes or the upcoming code freeze RC for Leap 4.0? All right. Then in that case, I'll hand it over to Brian to carry on the conversation about special node types. And I'll let you, if you like, try to drive. And if that's not working out, let me know, and I'm happy to drive too.
Sure thing. Hang on.
All right, I see your screen.
What? It worked. There we go. I really have no idea what makes the difference, where sometimes it lets it work and sometimes it doesn't. But here we go. It's up. So last time we kind of barely touched on the history provider. And I think we spent like 5 minutes talking about history provider. And as I recall, sort of the consensus was that it is a relatively broad and general definition, as providing history can be done in pretty much any format and for multiple different purposes, right? So what we landed on was, as a definition of what a history provider service is, it's a service that provides an API for clients to request data about historical events, and can be provided in any format. So really broad definition. And does anybody have any, what's the word, qualifications or details that should be added to that to make it more accurate and precise? All right. If not, then we can move into resource provider nodes. At the moment, I have this categorized as kind of a layer 2 thing. So the first thing I'm going to ask is this indeed kind of a layer 2 sort of solution, or would you argue? It is. Okay, cool. And would we call it a node, or is it just a service?
I would say it's comparable to something like the compute transaction endpoint, where it provides a service based on node information.
Right.
There's additional business logic on top of it, but it is directly, it's in the push transaction flow.
Okay.
Just like compute transaction, just like, things like that.
All right. Yeah, that makes sense. So it has to actually be directly processing that. I'll leave the terminology as node for now. All right. And I think Aaron drafted this initial language here. So Aaron, do you want to kind of give the quick overview of this resource provider node definition?
Sure. These are, I think, obviously, since I wrote it, I think that's kind of accurate. It basically is before a user signs a transaction, the transaction is passed to this node or this service, whatever we want to call it. And it is evaluated for issues. And if issues in terms of resources are detected, it returns a modified transaction to the client based on its recommendations of what could be changed to resolve those resource issues. And that the user can accept it, or if it's validated and automatic, then the user signs, and it's just a normal transaction at that point. But it is a user experience enhancer.
Okay. And then you have this note here, which I'm gonna sort of propose that we move into this follow-up section, which is basically explore resource providers as an official Leap plugin in the future, right?
Yeah, it's currently a Node.js application. There's an example we wrote on GitHub, but if it were more easy to run and just kind of configurable drop-in, it could be a revenue stream for operators, and it could also decentralize this infrastructure just like APIs are decentralized. The more of them, the better.
Cool. Sounds good. All right. So I think that sort of takes us through the list of identified node types. Sort of next steps that I have captured here are to go into capturing best practices for each of these node types, so we can kind of hop back up to the beginning, at least for the ones we haven't started talking about that. So, what are the device requirements for it? It's like, yeah, this needs a lot of hardware or a lot of disk. This needs a lot of RAM. Those sorts of things. Node EOS configuration best practices with regards to things like chain API, producer API, net API, all of these sorts of things. And then network configuration best practices. And I should, maybe to distinguish this, I should say networking. I'm talking about like, you should put a load balancer in front of this, right? Like those sorts of things. So before we like hop into doing that, does anybody sort of have any motion they'd like to make for sort of, doing something else first, or revisiting any of these?
Well, I have a question on history, since
Sure.
breeze through it there. So history comes in many forms and fashions. So are we just going to leave a general statement, or we wanted to break that down more into, kind of like full history of everything, specific history of like just account token balance, or, like history?
Yeah, I think there is something. Yeah, there's something interesting there from a use case perspective. So it might be valuable for this to capture like, what are the distinct sort of scopes of history for different use cases, right? Is that kind of what you're saying?
Potentially.
Okay.
I didn't really have anything specific in mind. It seems like history is a big topic and we have like one sentence. So,
right.
Is that the right level of detail you want? Because if you want to get into like API sizing and how much space it takes and compute, well, depending on what you're doing with your history solution, the answer is very different. It could be, terabytes of RAM, or, 5 gigs.
Yep. So I don't know if this is the right way to approach this, like more from a use case perspective, or if it's more like from a, specialized type of history provider sort of perspective.
Well, we can start from use cases. That's probably a good way. And we can start with maybe the first one, which is the, Aaron, give me the details here, but the API that's part of Node EOS. Well, there's like get block, which is kind of a history thing. Get a block, any block in the past. And then there's the get account, which returns the list of tokens or list of accounts that are available for a given key.
Get actions? Is that the one you're talking about?
Is that a history thing, or?
Yeah, I don't know if a get accounts, unless that's in a different solution that I'm just unaware of.
No, good.
Oh, I see what you're saying. Gotcha.
And that returns traces related to a given account.
So like how many of these like standard V1 chain APIs are not really, or would we consider as history solutions potentially? Because they're not really like, which of the chain APIs is needed for, current stuff, and how much is used historical stuff? Because they're clumped together in one set of APIs. And is that what we want going forward, or we want to separate those two? Because like when Node EOS starts, if you enable the feature, it generates a whole list of accounts and accumulates all that in memory, and it's nicely there for querying. But it's that current thing, or I don't know, how do you determine what's that history?
It's a good point.
This is not one.
There's also, this one may seem silly, but there's also a question of what current means in the context of the blockchain. But yeah, so broadly, that maybe the categories are like getting current state data, getting historical events, getting historical state data, right? Does that seem like a good sort of broad categorization?
Well, and I guess there's more in terms of if we consider Antelope doesn't require a system contract which has a token, right? Because that's optional. But if we add a system token, then there's a bunch of APIs that deal with having a system token and stuff. Are those current state? Because they're very specific to the implementation of the system contract that you chose. Or, I'm getting too philosophical, right? So there's ways of organizing the data in the current state, which requires history in order to generate that state. So for example, give me the list of all the tokens that this account owns, or give me all the users who own this token. That's current state, but it needs a whole lot of history in order to generate that. And Node.js doesn't track that. Right, so there's Light API that tracks that. The Fuse has a thing that tracks that. I don't know, maybe Robo probably has a thing that tracks that. Right, but that's current state, right? But it's not tracked by Node.js.
Yeah, and then you also have like get account by authorizers, which is available, but only if you've enabled the account queries option. So, and then also in the next release, we're going to have already in 3.1 you have block printing, but in 4.0 you don't have block splitting and ship block splitting. And so, again, what's your definition of current if you're not keeping all of those?
Right.
I think for the context of this bullet point, it's anything that's not current is what we would deem history. But the get accounts by authorizers and the balance stuff, those are still current state. They're updated in real time, and there's nothing historical about them. They are derived state.
I guess that's a good way of putting it.
Yeah.
The blockchain state as it's executed by the system contract, and then there's state that's derived based on the knowledge of how those system contracts work.
Yeah, there's everything that's available if you start from a snapshot versus stuff that's available if you've been running for a while, depending on settings.
Although you could argue that the snapshot is just a version of you've been running for a while.
Well, the snapshot does not
generated.
The snapshot does not include ship data or block data. It only includes current state.
But only includes some of the current state.
Sure, if you're considering current state things that provided by external history solutions that you've mentioned.
That's why it gets complicated to.
Yeah. I'm going to take the optimistic view that the fact that I'm lost is a good thing for this conversation.
Correct.
Not alone.
So, okay, I'm not sure exactly what's useful to capture here. Just to sort of have thrown some spaghetti at the wall here.
So that there's current state that's calculated by Node.js, and there's current state that's calculated by external tools.
Right.
So there's two ways of getting current state. And then there's historical state, which, has to do with something that's in the past. It's not current. Which, Node.js provides, ship or the blocks log. And there's external tools that provide get transaction or, trace history, or I guess trace history is built into Node.js, but, so.
Not really. Not unless you enable the transaction trace stuff, right? You don't get that by, unless you turn on the new transaction trace track.
So just to clarify, I think what you said here, Matthew, is basically a more precise restatement of what I had as like raw versus derived. It's state calculated by Node.js versus state calculated by external tools. That would be the same thing, but more precisely stated as raw versus derived, right?
I think so.
Okay.
And that kind of changes this bucket's name. It's no longer just about history. It's about external services that consume the data and repurpose it. That's a really long, bad way of saying it, but
Yeah, I think in its most broadest sense that kind of is my intention, at least. We should align and see if that's the right way to look at this. But because there are multiple ways of getting at the same value, and one of those, of course, is external services, right? So yeah, is it not? But I think it's still about providing history. The problem is that there's also state mixed in with it, which are arguably conceptually it's one and the same, or conceptually they're very different things for different purposes, right?
Yeah, and I mean, if you want to slice and dice it a different way, there's, also generic, APIs that allows you to build, maybe not generic, is the right word, but allows you to build custom queries to do like kind of whatever you want, like, GraphQL or something. And then there's other things that are very specific. Well, you can just query this thing in this pattern, right? Get me the accounts. What's it? Get me the email. Other ones are like, do some complicated thing, which, you
Right.
don't be an expert in how the data is organized in order to make heads or tails of it.
unless we want to outline all of them, it seems like everything we're describing is
What blue paper?
yeah. But the line above it, the event capture services, they feed these kinds of solutions regardless of what they do. And there's a
Correct.
variety of things that they can do. Like we're talking from history solutions like Hyperion and Robo to the Atomic Assets API to the Light API to even Firehose technically. It's like Firehose is a capture service. And then it feeds it right back out, but
Which is fine.
it just kind of falls into this bucket, which is a really vague, like, do whatever you want with the captured events bucket.
Well, in some ways, I think that's powerful. Right? I agree, it's really vague, but it's also powerful, right? Because we're saying, like, yeah, there's a thing and it outputs data. And then, by the way, other things can do pretty much anything with that data, right? Yeah. I don't know if this is a helpful exploration or not, but another thing I was just thinking about is like, what are the use cases for the state history data itself? And I don't know if these statements make any sense, but one is like to verify I just came up with an arbitrary term here, but the canonicity of state, right? Like, is this the like verifiable deterministic state at a certain point, right? Another is like retrieving preconditioned data for building an action as part of a transaction, right? Like, I need to know what the data is so that I know what I want to do in an action, like as an app, if that makes sense. Does that make sense, or does it sound like I'm rambling like a crazy person?
I'm careful with the terminology of state canonicity or state verify. That terminology is problematic for Leap because it's not the same as like something like Ethereum. It's not completely different.
So is it? Go ahead.
I was going to say, I think to loop all the way back to the next goal of classifying these in terms of requirements, this one just, unless it's broken out into individual solutions, it's most likely not going to be able to be classified because each solution requires different requirements, like different hardware requirements.
Yeah. Okay, I think we'll call this a parking lot item for now, and I'm going to capture as just sort of a follow up for this. Gosh, what is this exercise really? It's like identify
what would be useful is to be able to categorize these kinds of history solutions, if you want to call them that.
Right.
This kind of solution has these properties, this kind of solution has these properties, and maybe that might.
It's like it almost warrants its own list, just like this. That one bullet point could give an entire multi-page document like this.
Yeah, history. So it's like state and history can become its own taxonomy. Yeah, so it's like use cases and solutions. Yeah. State and history, use cases and solutions could become its own taxonomy. Yeah. Grammar stuff. Okay. And then I'm just going to push this down there for now. Oops. This is the exciting stuff, watching somebody format a document. So I'm going to just do it roughly so that it is not lost what I was trying to do. Okay. All right. So now we can get into talking about sort of these best practices. Any votes for where we start with kind of capturing best practices for different node types? Probably data history stuff.
Yeah. Focus on the ET.
Yeah, I would almost say the producer, and then the producer becomes, this is more, what I'm going to mention is more of like a methodology to doing this.
Yep.
Like whatever we deem the bare minimum is the baseline. And then other solutions are either above that or below that, or, because the minute we start talking about EOS versus WAX versus Telos versus a test net, like we can no longer give numbers. Like I can't say this much RAM. All I can say is that it's like way above baseline, or this is actually below baseline. And then whatever your baseline is for the network, like it's going to be 100 gigs for WAX of RAM. You would know that history is above that, for example.
Yeah, that's an interesting point. So is it worthwhile to attempt to capture device requirements? Because I guess what you're saying is there's different categories here. There's like, are we running this on a main net or a test net or a private network, right? Like a single node type of network. And then there's, as you said, even within that, different main nets, right, might have different requirements. So with those complexities in mind, is it still valuable to capture device requirements? Like for two node operators, is it valuable for you to be capturing that?
Well, maybe there's requirements that are not based on the amount of RAM or CPU. Maybe there's other requirements. I don't know.
Sure. Okay.
So the RAM varies depending on the amount of state that you need to store for your specific chain.
Yeah. So we could just capture that caveat and then anything else that's actually valuable across the board. Okay. So then, yes, I do think block producer node is probably the place to start. We did kind of start on this a little bit previously, and yeah, and then I sort of refined what we were trying to do because that was a first attempt. So we're gonna probably recategorize a few of these things, but okay. So from a device requirements perspective, and I do think this is probably the right place to start simply because on any of these networks, you at a minimum need at least one node producing blocks, right? So, and it could in theory be doing other things, but that's not the purpose of this point. So, yes, I guess the RAM and disk requirements vary based on network.
Well, so does the CPU, I suppose.
Yeah.
How many?
CPU, RAM, and disk requirements vary based on network, I guess, utilization, right?
And the network here, you mean the specific blockchain?
Yes, yeah.
I mean, I always use network for blockchain, but not everything.
I'll just say blockchain network utilization. All right. Are there any device requirements that kind of apply across the board as a best practice for block producers or block producer nodes? I mean,
one of the things is to change the idle time frequency stuff in your CPU governor. So the Attic Lab team back for some years ago created, like, there's a GitHub, I could probably find it, which has some performance tuning things. So one of the things we noticed is way back when that, the CPU that a transaction takes is much longer if the CPU has to wake up, process the transaction, than if the CPU is already kind of running at full speed.
mm-hmm.
So this is just some Linux kernel tuning parameters. How do you run Node EOS? You might want to set real time priority, like we do that on our block producer, for example. So that it always gets more priority over, rolling logs or something. So these kinds of things. Let me go see.
So it's like tune CPU based on, you said Attic Labs?
Yeah. Okay, I found it. The document has not been updated in a while.
Right. So it might.
The general concept.
Okay.
The link is in the chat.
Yep. Okay. Anything else?
I guess everybody uses Linux first. I don't know. Do we say, don't try to run this on your MacBook or Windows WSL2? You're meant to run this on, kind of bare metal ish, or close to bare metal as possible. I mean, people run it on AWS, but I don't know how many people try to run it on ARM processors in production environment. Maybe that's fine for developments, but we're talking about producing nodes, right?
Yeah. So preferably run Node on bare metal is one. And then there was another point that you made that was a good one.
The processor architecture. So x86, right? We're not running this on ARM.
Yeah, use.
And do we want something with ECC RAM? Especially when you have nodes that require a lot of RAM. I mean, a bunch of us don't run it on ECC RAM, but that is certainly the.
I don't know the sort of stylization of that. I don't know if it's lowercase or what, but
That's right.
Yeah.
Okay. Oh yeah, and then sort of OS. Do we have today any documentation of supported OSs?
Well, the release notes are has the list of supported OSs.
Right. Okay. So
we run it on a different one that's not listed, but
sweet.
We're using Debian 11, but the recommendations are Ubuntu 18.20 or 22.04. 18.04.
Not 18 anymore for the next release.
Yeah, the next release 18 as well. But currently it's allowed.
Right. Okay.
So, like, we used to have CentOS support back in the Block 1 days. That got dropped. I didn't hear anybody majorly complain. Seems like the blockchain ecosystem is happy with Ubuntu-based or Debian-based operating systems.
Okay. Any other key things under device requirements? I guess operating system arguably isn't device, but we're going to call it that. So,
I can't think of anything else right now.
all right.
The other thing I can think of is connectivity. Like certain node types require different levels of connectivity.
Yeah, will that fall under networking configuration, or is it a device thing?
I don't know.
Not sure if it's how you configure it. It's mostly what it's plugged into.
Yeah.
Like
Okay.
how big the pipe is.
Yeah, so it would be, what is that, sort of like requirements around like what NICs to use and that kind of thing, or?
Potentially, I suppose. Yeah, you want.
Like a bandwidth requirement in the first line item.
Yeah, okay, that's fair.
Yeah, depending on the network.
Network, bandwidth, and then device, CPU, RAM, and disk requirements. Yeah. Okay. All right, Node.js configuration best practices. Now, I don't know if it actually makes sense to sort of break this into chain API, producer API, net API, DB size, all those sorts of things. So that's the first question is, does it make sense to run through the different sort of plugin level things for how we configure it, or is it more just one running list of best practices?
Not sure where you're going with this.
So an example that from up here that we might have captured. Let me see. Right. So like here's an example that would be probably I'm actually not sure which of these falls under, but like keep number of peers low, right? So we already captured that, but
That doesn't have to do with the plugin.
yeah. Okay. So that might just be an indicator that maybe this isn't the right way to sort of break that up. So, but it is a Node.js configuration best practice, right?
For which?
And
It's what you put in your config files. So yeah.
Yeah. Whoops. Oh, I didn't capture all of these pieces. Sorry. All right. There we go. So just to review some of the stuff we previously captured, highly secure signing key, physically separated ideally. That might be something about device requirement, or yeah, how would you capture that? Might just be like a security best practice or something that I don't have a.
Yeah. But how many BPs use a hardware key? My guess is in the order of 0.
Yeah. So is it not a best practice?
The best practice that I know of is make a signing key that's specific only to signing, right? So that it can't be used for something else. So therefore it's, isolated to just put it on a server that's isolated from everything else as much as possible, and just make the key as specific as possible for signing blocks. But it has to be exposed on the node anyway. So what? Okay, you have it on a hardware key, and then it's available anyway.
Yep.
You can't do hardware keys on AWS.
So yeah, method available.
However, if you're running maybe a private blockchain in a private network, maybe you do have a hardware key. I don't know, but I don't think it's practical recommendation in a public blockchain.
Right.
Such.
Okay. Yeah, I think these are just more goals than they are best practices, right? Like Except for maybe this last one is a networking best practice, right?
Mhm. Which gets into very interesting discussion because there's various debates on how best to do these kind of networking best practices.
Right. Okay. Coming back up to the Node EOS configuration best practices, are there others that we need to capture? I guess just using this as a tool real quick, anything related to the chain API stuff?
Well, Chain API has a bunch of different, like you can enable the account query API, I forget whatever Kevin called it, which is part of the Chain API. So you can have that enabled or not enabled. So there's one API which has multiple configuration options.
It's really based on node type, less on plugin.
Right.
Like the best practice for the chain API in an API node is different than in a producer node, but they both use it.
Sorry. Just to clarify, that's actually what I'm talking about. For a block producer node, like what would you recommend to have enabled and disabled for these various things? Does that make sense?
Yep. I did not realize that the header of this section was block producer.
There it is. Cool.
Yeah. So in our block producer, the Chain API is enabled because we need to do monitoring for get info. Otherwise, it's not used. Producer API is enabled so we can update the block list or whatever as needed. The net API is always enabled, isn't it? And the DB size API is always enabled. Well, in our case. And we always want to be able to query how much, space the thing's taking up for monitoring. Oops.
And then the trace API also, or
Trace API, we don't use trace API, and you would never put that on a producer node.
Yeah. There's a lot of plugins that you should never enable on a block producer.
Well, I would like to not enable the Chain API. However, I need it for get info. So I think Michael's in the same boat.
I'm assuming ship is one of the plugins that you would have disabled for this node, right?
Correct. Right, and you don't want to run a snapshot from the producer API either, but it's in the producer API, but you never want to allow a snapshot to happen on the block producer. So the problem is the way the plugins are configured and the options that you need are orthogonal. Yeah, I need to enable this plugin to get this feature, but I don't want the other ones, but I get them all.
Yep. Yeah, okay, so you're saying that like right now it's sort of enable or disable at the plugin level, but there are really what you want is a bespoke set of features for each node type.
Correct. Which might be on different ports. So for example,
so that you can do networking stuff to block it or whatever, right?
Whatever, right? So the Chain API to do get info, anybody can query, that's not a problem. But the producer plugin to, change the blacklisting, well, maybe that should be on a different port and it's restricted to a different set of, IP addresses that can access. Right? But I don't have that control today. Like if I want that control, I have to put a load balancer or proxy, reverse proxy on everything and then handle all the which URLs I can do depending on who I want to be able to access something on a specific node. Or I just trust people that have access to things to not abuse it, which is kind of actually how it works today.
So I think it could be helpful. This is crossing out of the boundary of like configuration best practices of today a little bit, but just so that I can capture it and sort of reorganize later. For each of these, can we capture like why you have it enabled and what you wish didn't come with it for this particular type of node, if that makes sense?
Sure.
So like,
this one's enabled because I want get info, because that's the only way I can monitor if the chain is active. Now, with the Prometheus plugin that's in 4.0, maybe I don't need this.
Okay.
But that's the only reason I have this name.
And is there anything that comes with it when you enable that you wish didn't?
Yeah, all the rest of it.
Yeah, everything else.
Right. I just want get info. That's it.
This might be a case for just moving get info out of the chain API into its own always on thing. I can't think of a situation where you wouldn't want get info on a node.
Right. Like maybe it's not a plugin in the future. It's just part of the core. Right. Like,
Well, there is the nicety that it's currently possible to run Node.js without any HTTP enabled at all.
True.
So I would prefer, like, I get making get info its own thing, but I still think it should be enabled, because there is a use case of running Node.js without any HTTP supportable.
okay. All right. What about the producer API? It's enabled for.
Updating blacklist, whitelist, gray list.
Stopping, starting.
Oh, sorry.
Anything else?
Yeah, well, I don't want the make snapshot API.
Yeah.
Yeah, it's odd that snapshots live there. Yeah, not sure why that was put there. Seems like it ought to go in chain. Or really it ought to be its own thing, but I'm not sure why it was put there to begin with. Seems strange.
Somebody didn't want to make another plugin. Oh, let's just stick it in.
Yeah, but it seems like the default idea would have been in chain, although producer's the one that's got block boundaries, so that's probably why. And
Couldn't there even be an argument that it shouldn't necessarily be part of Node.js if you had a sort of a downstream history solution that was sort of building derived data about the chain, like verifiable derived data about both blocks and state, right?
If the blockchain would recover itself without having to fiddle with snapshots, then ideally this wouldn't even exist.
yeah, ideally, I think snapshot would be the on-disk representation of state, so that you always effectively start and stop with a snapshot. But yeah, we're not there yet.
Right. I think I'm more saying like the thing that makes the snapshot. Anyway, I think it's a different topic. Anyway, it has more to do with the. Well, we don't need.
This needs to be here because Node.js doesn't work unless you have this capability. So it has to be inside Node.js somewhere.
Well, the ability to import it, right?
Well, how do you, if you can't export it, how do you import it?
Yeah. Well, I think this might be rabbit hole, but I'm saying like, so for example, something like Firehose in theory could build a snapshot, right?
Yes.
Not unless it's playing everything, though. I mean, like there is bits of data that aren't going to pass through Firehose because they're not current. Like that, the Firehose won't replace snapshots unless you've started the chain from scratch.
Yeah, and Firehose depends on Node.js having a snapshot, so it's like this recursive.
I see. Fair enough. Okay. Cool. All right. What about Net API?
So Net API is there to allow me to add and remove peers, right? Oops, it's not needed a peer. Row peer.
Anything else?
That's all it does.
Well, and get status on.
Yeah.
At the status of the connections, and then add and remove them. Yeah. So we use it for monitoring, so we can see who's connected and who's not connected. Oh, they're disconnected, then go chase down why it's disconnected. And then to actually add and remove the peers, the peer-to-peer, P2P peers.
Yeah. And then is there anything that it does that you wish didn't kind of come with it?
I think that's all it does.
Okay. DB size API?
It has only one thing. It gets the size of the state in round. So read only, very easy. What I wish is it didn't fall under the list of published APIs and get API endpoints in the chain API.
So, okay.
Because this is an internal thing. Why do like the chain API is meant for like public consumption, kind of think about it. Like this is my node operator monitoring, or at least that's how I take it. So when we publish the list of available API endpoints to the public, we remove this one from the list and we block it from the proxy. We don't let it cheat.
But doesn't the DB size API also like let you actually get like tables and stuff, or is that a different piece? Oh, okay.
It just returns a number.
Okay.
56 gigs or whatever.
Right.
Just in bytes.
And why is it harmful for that to show up in API endpoints? It's just because you use it internally, so it's more of a least privilege type of thing. You don't. Why would people even need to know about it?
Why would somebody need to know it? Yeah. Right.
Yeah.
From a security perspective, you don't ask why not, you ask why. So
yeah. Okay. All right. Trace API?
No.
It's disabled, so it doesn't matter. Okay. And ship also disabled, doesn't matter. Do not snapshot on the block producer, so it doesn't matter. Okay. Other networking configuration best practices. I guess there's a blurry line between here where we talked about like blocks only relays, public and preferred stuff, because some of that's probably implemented via networking, right? Or is that all just configuration stuff?
Okay, so we only have 4 minutes here, so it's not very much.
Oh, shoot. Yeah, I lost track of time. Thanks for pointing that out.
So maybe I think this could get into a big topic. Maybe we can pick it up next time.
Yeah. Cool. All right. Well, I guess with that, I'll, thanks for pointing that out. Any sort of last comments on this, or should I go ahead and hand it back over to Daniel?
And it feels like a useful exercise. Starting to get this written down, because I think this is in like the, what do you call it, OG block producers heads, and it's not written down anywhere. And I see, every time there's a new block producer, they're like, but nothing's, I don't know. And it's like, they're just all confused because none of this is written anywhere.
Well, I also think it'll be valuable over time to, like, as we get through other types of nodes, we can start to tease apart the features of the different plugins, for example, and when they are and aren't desired by different nodes. And it might actually lead to architectural changes, not just recommendations, so. Anyway, cool. All right, Daniel, you can take the mic.
All right. Thanks, Brian. I have nothing to add. It was great discussion. +1, it's great to see this knowledge coming out of the heads of our OG node operators, and the ENF taking an active interest in making sure that we're architecting this software in a way that makes sense to the way that we operate it. So it's awesome progress here. And with that, I think we can wrap things up. We'll continue the conversation in a week. So have a great day, and happy Pomelo grant hunting, everybody.
Thank you, everyone.